cos 2x. This is the question. But I'm going to solve this question using what is f of z. First, I'm going to take f of z is equal to p plus iq. This is f of z. P plus iq is equal to f of z. I'm multiplying f of z with I. So I into f of z. Left hand side I into f of z. Right hand side also you have to multiply with I. So I into p plus I square into q. So I into f of z is equal to ip. I square is minus 1. So minus q. So take equation number 1 and equation number 2. These two you have to add. If you are adding, left hand side is f of z plus I into f of z will be 1 plus I into f of z, which is equal to, right hand side is a real part you have to add, imaginary part you have to add. So p minus q is the real part, plus I into p plus q. I am taking 1 plus I into small f of z, I am taking capital F of z. P minus q, I am taking capital U. P plus q, I am taking capital V. So what is given here? Given problem is P minus q. So I am taking P minus q as capital U. Understand? So therefore, P minus q I am considering, I am taking as capital U. So capital U is equal to sin 2x cos h2y sin 2x cos h2y. Okay, sin 2x divided by cos h2y minus cos 2x. By Milne-Thomson method, u is given. Here, u is given. P minus q is given in the problem, but we have changed to u. So, u is given. Suppose p plus q is given in the problem, in the given problem, we will take v is given. Okay. So, by u is given, the Milne-Thomson method is capital F of z is equal to integral phi 1 of z comma 0 into dz. This is the formula, minus I into phi 2 of z comma 0 into dz. Let us see what is the phi 1 of z comma 0, phi 2 of z comma 0. Phi 1 of z comma 0 is equal to dou u by dou x. Phi 2 of z comma 0 is equal to dou u by dou y. U is given sin 2x. So u by v method, you have to differentiate. How to differentiate? U by v method. That method is d differentiation of u by v is equal to, denominator is v square, numerator is v du minus u dv, right? The same concept here we are going to use. So v is cos h2y minus cos 2x, that is dou u by dou x. So cos h2y minus cos 2x whole square. Numerator is cos h2y, v is, so v into du, cos h2y minus cos 2x. U is sin 2x. Sin 2x, if you are differentiating, 2 cos 2x minus v into du, v du minus u dv. So u is sin 2x, dv, v is cos h2y minus cos 2x. This one is we have to differentiate. Cos h2y, if you are differentiating with respect to x, will be 0. Minus cos 2x, if you are differentiating with respect to x, it will be 2 sin 2x, minus 2 sin 2x. Already there is minus. So minus or minus plus. That's why I am writing here 2 sin 2x. Now, what is the phi 1 of z comma 0? Dou u by dou x. There, for x you have to apply z, for y you have to apply 0. So for z, for x you have to apply z, for y you have to apply 0. So cos h2y, for y 0. So cos 0 minus cos 2z into 2 cos 2z. For x, z, for y 0. Everything I have applied. Cos 0 1. So 1 minus cos 2z into 2 cos 2z minus 2 into 1 minus cos square 2z divided by 1 minus cos 2z whole square. So 1 minus cos 2z minus into 2 cos 2z minus a square minus b square can be written as a plus b into a minus b. So 1 minus cos square 2z can be written as 1 minus cos 2z into 1 plus cos 2z divided by 1 minus cos 2z whole square. So 1 minus cos 2z in the numerator, in the two terms are having 1 minus cos 2z, denominator 1 minus cos 2z whole square. So you can cancel. So 2 cos 2z minus 2 into 1 plus cos 2z divided by 1 minus cos 2z. So numerator is 2 cos 2z minus 2 minus 2 cos 2z. 2 cos 2z first term, third term cancel. So answer is minus 2 divided by 1 minus cos 2z. 1 minus cos 2z, that is the formula sin 2 sin square theta, can be written as 1 minus cos 2 theta. So minus 1 by sin square z. So phi 1 of z comma 0 is equal to 1 by sin theta is equal to square. Minus I into v divided by u square plus v square. So equating the real and the imaginary parts. Equating the real and imaginary parts. What is x? U divided by u square plus v square. What is y? Minus v divided by u square plus v square. Next, what is given? Modulus z minus 1 is equal to 1. As I told you earlier, z is x plus iy minus 1 is equal to 1. Real part you have to combine. So x minus 1, modulus x minus 1 plus iy is equal to 1. What is the modulus x plus iy? Modulus x plus iy can be written, which is equal to square root of x square plus y square. Am I right? So here x minus 1 whole square plus y square is equal to 1. Both sides I am square root will come. So both sides I am squaring. So x square, x minus 1 whole square. If you are expanding, x square minus 2x plus 1 plus y square is equal to 1. 1 minus 1 0. So x square minus 2x plus y square is equal to 0. What is x? Already we know. U divided by u square plus v square. What is y? Minus v divided by u square plus v square. Substitute here. So u divided by u square plus v square whole square minus 2x u divided by u square plus v square plus y square minus v divided by u square plus v square whole square. So first term u square divided by u square plus v square whole square. Second term minus 2u divided by u square plus v square. V square divided by u square plus v square whole square. So in the denominator, if you are taking LCM, u square plus v square whole square, numerator you can add u square, last term plus v square, second term minus 2u into u square plus v square. Okay. So therefore, u square plus v square is common. U square plus v square, if you are taking as a common, into 1 minus 2u divided by u square plus v square whole square is equal to 0. U square plus v square in the numerator, denominator is u square plus v square whole square, cancel. So one time u square plus v square, it will occur in the denominator. So 1 minus 2u is equal to 0. 2u is equal to 1, u is equal to 1 by 2, which is a straight line in the w plane. U is equal to 1 by 2. How to draw in the figure w plane? You have to draw x-axis, y-axis. In the x-axis u, in the y-axis v. Always along u axis v is equal to 0. Along v axis u is equal to 0. Where you will draw u is equal to 1 by 2? In the axis u. U is equal to 1 by 2. Straight line. This is the w plane. In the z plane, already we know x minus 1 whole square plus y square is equal to 1. This is in the z plane, x-axis, y-axis. Z plane, xy axis. In the w plane, uv axis. Okay. So we are changing. So next one is when the function f of z is equal to u plus iv is analytic. Prove that u is equal to constant and v is equal to constant are orthogonal. So orthogonal means here you have to find the slope of the given one. So given f of z is an analytic function, Cauchy's-Riemann equation is ux is equal to vy and uy is equal to minus vx. I am considering u is equal to the constant a, v is equal to constant b. So that is the formula dou u by dou x plus dou u by dou y into dy by dx is equal to 0. So from this you can write dy by dx is equal to minus dou u by dou x divided by dou u by dou y. You can take which is equal to m1, slope 1. Next, from dv by dx, if you are writing dy by dx is equal to minus dou v by dou x divided by dou v by dou y. By CR equation, what is minus vx is equal to uy. So for minus vx is here, so that's why we are writing uy, vy ux using the CR equation. This is called as slope 2. These two slopes, if are intersecting m1, m2, so m1 as well as m2 you have to multiply. The answer will be minus 1. So two family of curves form an orthogonal system. M1, M2 is equal to minus 1 means orthogonal system. Okay. So I'll tell you again. This is the orthogonal system. So here, find the analytic function f of z is equal to p plus iq. If p minus q is given, directly u is not given, v is not given. To confuse us, they are given p minus q. We don't know, we know only if u is given, v is given, then only we can solve. But here, the p minus q is given, we have to change. Okay. So p minus q is given. Let f of z is equal to p plus iq. I into f of z. Both sides I am multiplying by I. I into f of z is equal to ip plus I square q. So I into f of z is equal to ip minus q. Okay. So these two, if you are adding, you will get p minus q, p plus q. P minus q, that is given in the problem. So p minus q, I am taking as capital U. P plus q, I am taking as capital V. So u plus iv. That means u is equal to p minus q. Now we know u is given by Milne-Thomson method. F of z, the formula is integral phi 1 of z comma 0 into dz minus I into integral phi 2 of z comma 0 into dz. So we can solve the problem when u is given, when v is given. There are only two methods. U is given, v is given. Okay. Otherwise, whatever is given in the problem, we have to change to u as well as v. P minus q is given in the problem, but we have changed it to u. Okay. So this is very important. Understand? Okay. So thank you.